what some of those recommendations were. So in terms of structure, we found it quite interesting with all of our research. In some sense, we kind of expected that many of the current curricula and the newest curricula might be using a structure other than strands. And we were surprised to see that in most cases, the curriculum were organized by strands rather than some other organizing structure. However, we also noticed that the mathematical processes were regarded and highlighted, and in many cases, the curriculum described how they interact with the content. And as well, the discussion of strands in most of the curricula and the research talked about the integration of the strands, so that the strands are not seen as silos, that they're integrated, and that all of these ideas come into play. We also recommend that there be a continuum of important mathematical ideas. In many of the curricula that we looked at, there were actually pop-ups that showed how a concept is developed over time. And some of this, of course, is built on some of the current learning trajectory research. And another thing that we noticed in some of the work of the most current curricula were the idea that it was digital. And by digital, I don't mean a PDF that's online. It's a dynamic curriculum. So that it would be possible to have pop-ups, have information, have resources that are all connected. I guess the way I would think about it was kind of a one-stop shopping, so that what a teacher might need would be connected to that curriculum, and that it would be responsive to new ideas as well in terms of resources as they're developed. We also had recommendations in terms of content that needed to be considered and content that maybe needed to be looked at slightly differently. So, for instance, we suggested making sure that new research is included. As I mentioned, there's been quite a bit of work on, particularly in the early math, on learning trajectories, which often sounds like a linear kind of trajectory, but it actually could be a network of mathematical ideas. So to look at how mathematical ideas might be connected, and what is it that we know about how students learn and how they develop concepts. What are some new areas of content that are emerging? And what are some cross-strand and cross-curricular connections? We also, by looking at the research and at the other jurisdictions, brought forward some topics which have been emerging to be quite topical, quite relevant to our current situation, as well as important for students to learn. So such as mathematical modeling, financial literacy, and computational thinking. And to think about those ideas in connection to students' own experiences so that they have meaning for students. We also suggested thinking about expanding our understandings of spatial reasoning, and I'll give you an example in a minute, but really thinking about how that affects not just measurement and geometry, but many other aspects of student learning in mathematics. But we also recommended that with whether it's the restructuring of content that was there before or with the addition of new content, that teachers will need support with this new knowledge. They may need to see what a learning continuum looks of some of those new knowledges. They may need to see the ways that ideas connect to other ideas. They may need to see videos of what this learning might look like, samples of student tasks, glossaries, etc. So the idea that with new content also comes possibly new learning for teachers.